Hello, hello. Thank you so much for tuning in today. I wanted to share with you just a quick little lesson on inferential statistics. Had a individual in our tutoring group the other day asking about this, and so I thought I'd create just a quick video to help you understand some of the common tools that we use in inferential statistics, basically how scientists and researchers test ideas with numbers. Okay, so here's what we're talking about with inferential statistics. Imagine that you want to know something about a whole school, but you only ask a few students. What inferential statistics does is helps us to guess what's true for the big group based on the small group. That's what we call inferring. From the data that we've collected, what can we infer about a larger population? They tell us, did this happen by chance, or did this really mean something, right? And so we take the data that we have, we run it through some formulas, and then we can make these inferences about the group as a whole. One of the tools that's used is the chi-square method. What this does is it actually compares categories. And so here's just a little simple example. If you think about like counting M&Ms in a bag, do we really have the same number of red, blue, and green, or is one color way more common? Okay, we want to use this because the data is in groups, like nominal groups, like yes, no, boy, girl, red, blue. When we have just these nominal groups like this, it's easy to come up with the data that's necessary for chi-squared. Okay, an example might be, do boys and girls prefer video games equally? Right? If they're answering yes or no, then we can run a chi-square test to see how the data actually compares and if we can infer those results onto a larger group. An example from behavioral health would be a school counselor wants to know if boys and girls are equally likely to attend the school's stress management workshop. So out of 100 students, more girls than boys signed up. A chi-square test checks if that difference is just chance or if gender really matters for who signs up. Like I said, there are some formulas that we use with that data. You don't need to know those formulas for the NCE, so I'm not even going to cover them. It's just going to add confusion. But basically, here we're looking at two different sets of data to see if we can infer if that difference between them is just chance or if it actually matters. A t-test is a little bit different. This compares the average scores of two groups. So think of it like a race. Does Team A run faster on average than Team B? We're going to use this in order to see if the two groups really are different. So another example would be, did students who studied with flashcards score higher than those who didn't? So we're looking at average scores. We're running a t-test to compare those average scores to see what we can infer about the larger population, and that's what a t-test is. An example from behavioral health, a researcher tests whether a new mindfulness program helps teens lower anxiety. She compares two groups. One group practices mindfulness for 4 weeks and the other does not. A t-test shows if the difference in average anxiety scores is real or just a fluke. Okay, so when we run that t-test, we're going to be able to draw conclusions from that data based on whether it's statistically significant or not. That's a whole another lesson when we're looking at levels of significance. But a t-test is going to measure the averages of these two groups to see if it's a real difference or if it's just a fluke. And then we have ANOVA, or analysis of variance. Okay, this is kind of like the t-test, but for 3 or more groups. So think of it like a pizza party. Do kids who eat cheese, pepperoni, or veggie pizza report being the happiest? So we're going to look at the averages of all of these groups and then compare them. And we want to use it to see if there's a big difference among several groups. Okay. Another example, do different teaching styles, online, small group, or big lecture, change the test scores? We would find the averages of all of those test scores, run it through the ANOVA formula, and then we'd be able to draw some conclusions and see if there's an actual difference or if it's just by chance. Here's an example from behavioral health. A psychologist compares 3 types of group therapy for depression: CBT, supportive, and art therapy. She measures the average depression scores after 8 weeks, and then ANOVA shows if at least one therapy really works better than the others. So here we're comparing 3 or more different groups. And then MANOVA, a multivariate ANOVA. Okay, what this looks like, what this does is it looks at more than one result at the same time. So think of it like this. We're checking both grades and happiness for kids in different clubs. We're not just looking at one outcome, we're looking at multiple outcomes, which is why it's a multivariate ANOVA. Okay, we're going to use this when we care about more than one outcome. Okay, an example might be, does playing sports affect both fitness and friendship levels? We might be able to just think of it and draw the conclusion that it probably does. But with a MANOVA, a multivariate ANOVA test, we can determine whether it's actually a significant difference. An example from behavioral health. So a community clinic wants to know how different trauma-focused therapies affect clients. They don't just look at one outcome, but they can check both depression and sleep quality after treatment. A MANOVA test is going to determine whether the type of therapy influences both outcomes together. And again, there's formulas for this. I'm not going to learn the formulas. We don't need to know them. But we do need to know that we're looking at multiple outcomes with a multivariate ANOVA or a MANOVA type of test. And then we finally have ANCOVA, an analysis of covariance. Okay, what this does is it checks differences while controlling for something else. So seeing if kids in different math classes scored differently, but also adjusting for how much they already liked math. So maybe they started liking math, and that's going to impact whether they enjoy those math classes differently. We want to use it in order to be more fair when comparing groups. So does tutoring help grades even after considering kids' starting test scores? Okay, so we're controlling for the fact that when the study began, there may already have been a difference in the populations that we were studying. And that's ANCOVA, analysis of covariance. An example from behavioral health, a counselor tests if online therapy and in-person therapy reduce social anxiety differently, but she knows some clients started with higher anxiety than others. ANCOVA adjusts for those starting scores so that the comparison between online and in-person is more fair. Okay? Analysis of covariance means we're testing this, but we're taking into account changes that existed already when the study began. Okay? So here's just a key differences chart. When we're looking at all 5 of these tools for inferential statistics, you can download this chart with the slides that are linked in the video and just kind of look at them side by side. Sometimes it's really helpful when you're studying something to see how they compare by looking at them in a chart like this. So the big takeaway is that these tools for inferential statistics answer different questions. All of them help us to know, is this real or is it just a chance that these scores are? Okay, and so the scientists and researchers pick the test based on how many groups they're comparing, what type of data they have, and whether they need to adjust for other things. So, hope this has been a helpful understanding of inferential statistics and some of the tools that we use. My name is Josh. I'm the owner of NCEExamPrep.com. If you have any questions, feel free to reach out. You can find me at NCEExamPrep.com. There's a little web chat widget, and I'd be happy to visit with you if there's anything that I can do to support you in passing the NCE. Thanks so much.